Example number 6. Solve the equation 3 sine squared theta plus 5 cos theta is equals to 5 for theta between 0 degrees to 360 degrees. Example number 6. Solve the equation 3 sine squared theta plus 5 cos theta is equals to 5 for 0 degrees less than or equal to theta less than or equal to 360. That means theta is between a range of 0 to 360 degrees inclusive, isn't it? So if you look at this case, we've been given 3 sine squared theta plus 5 cos theta to be equals to 5. Identity being tested is the Pythagorean identity. And Pythagorean identity will tell you that sine squared theta plus cos squared theta is equal to 1, isn't it? So it means you can get rid of sine squared theta so that everything is in terms of cos using the Pythagorean identity, isn't it? So it means for us to get rid of sine squared theta, we make sine squared theta the subject of the Pythagorean identity. So sine squared theta is 1 minus cos squared theta, isn't it? So in our original equation, where there is sine squared theta, we substitute with 1 minus cos squared theta, isn't it? So what you are substituting in your bracket, so we have 3 into sine squared theta, which is 1 minus cos squared theta, then plus 5 cos theta is equal to 5. Now everything is, we only have, not everything, but we now only have a cos as the only, we only have the cosine as the only ratio, isn't it? So if cosine is the only ratio, it means we can now solve that equation, isn't it? Are we together? So remember, solving the equation depends with the methodology you are using. The equation can be solved when the unknown is in power form, you can solve it using logarithms, isn't it? When the unknown is in quadratic form, you solve it using the quadratic method, isn't it? When the unknown is maybe a coefficient form, you solve it by dividing both sides by that. You use the appropriate methodology in that case, isn't it? Like if you look at this our equation, the first thing we do is to simplify it, isn't it? So if we simplify this equation, opening the first bracket, 3 into 1 minus cos squared theta, we get 3 minus 3 cos squared. A factor which is outside the bracket multiplies all the factors inside that bracket. So we have 3 minus 3 times 1 is 3 minus 3 times cos squared theta is 3 cos squared theta. Then plus 5 cos theta is equal to 5. So 5 coming on the left hand side of the equation, it becomes minus 5, isn't it? It's equal to 0. Because this problem is in form of a quadratic form, isn't it? So we can't simplify it. So when we are simplifying, we start with the term which is squared, isn't it? Remember the term which is squared is cos squared theta. So what is the coefficient of cos squared theta? The coefficient of cos squared theta is negative 3. Are we together? So we start with the negative 3 cos squared theta, then followed by 5 cos theta. Then here we were left with 3. So positive 3 and negative 5. Positive 3 and negative 5, we are going to get negative 2 if you simplify, isn't it? So that one is equal to 0. So you simplify that equation. So you can say let cos theta to be y, so that you are able to see the quadratic, the standard quadratic equation there, isn't it? So you let cos theta be. So let cos theta be y. So where there is cos theta, you put y. So we are going to have negative 3, then y squared, then plus 5y minus 2 is equal to 0. Are we together? So where there is cos theta, we substitute with y. So in that equation, we now have negative 3y squared plus 5y minus 2 is equals to 0. Now that is a quadratic form, and the standard form of a quadratic equation is given by y is negative b plus or minus square root of b squared minus 4ac over 2a. So can you now construct your coefficient? A is negative 3, b is positive 5, c is negative 2, isn't it? You extract a, b, and c from that equation. So you can see a is negative 3, b is positive 5, and c is negative 2. So let us substitute those values in the quadratic formula. So we have y is negative of b. Where there is b, you put the value of b plus or minus square root of b squared. B squared is 5 squared will give you 25 minus 4ac. 4 times a times c, that is 4. 4 times 3 is 12 times 2, 24. So remember, negative 3 times negative 2 is positive 6, isn't it? So positive 6 times 4 is 24. So we have 25 minus 24, then everything is over to a. 2 times negative 3. So there we have y is negative 5 plus or minus square root of 1. Square root of 1 is 1, isn't it? Over 2 times negative 3 is negative 6. So we have y, the first value of y, you take the positive sign in the middle, isn't it? So the first value of y will be negative 5 plus 1 over negative 6. Then the second value of y, you take the negative sign in the middle, isn't it? So there you have negative 5 minus 1 over negative 6. So what is y1 here? Negative 5 plus 1 is negative 4. Divide by negative 6, you get 2 over. So y1 is 2 over 3. Then y2, negative 5 minus 1 is negative 6 over negative 6 is positive 1, isn't it? So we have the two values of y. So y is either 2 over 3 or 1. Y is either 2 over 3 or 1. But y was cos theta, isn't it? Meaning where there is y, we put cos theta. So where there is y, we put cos theta. Because y was equivalent to cos theta. So how do we get theta? We start with the first one. So the first case, we have cos theta is equals to 2 over 3. Meaning theta is the cos inverse of 2 over 3. So you can see 2 over 3 does not have a sign. It means it has a positive sign, isn't it? So we are looking for the cos inverse of 2 over 3. Then we are going to look for the quadrants where the cosine is positive, isn't it? The quadrants where the cosine is positive. So let us draw our 4 quadrants of a unit circle. So all students take calculus. So in the first quadrant, we have an acute angle, we can say angle beta, isn't it? The second quadrant is 180 minus beta. The third quadrant is 180 plus beta. The fourth quadrant is 360 minus. So can we now find out what is the cos inverse of 2 over 3? Cos inverse of 2 over 3 is 48.1 degrees. So 48.1 degrees is the angle in the first quadrant, 48.1 degrees. Are we together? Then the angle in the second quadrant will be 180 minus 48.1 degrees, isn't it? So what is 180 minus 48.1 degrees? 131.9 degrees, isn't it? 131.9 degrees. Then you move in the third quadrant, 180 plus 48.1 degrees, you get 228.1 degrees, isn't it? Then in the fourth quadrant, 360 minus 48.1 degrees, you get 311.9 degrees. Are you using a calculator? 360 minus 48.1 degrees. We have 311.9. So from there, which angles are we looking for? We are looking for the angles where the cosine is positive, isn't it? The quadrants where cosine is. So the first quadrant, all of them is positive, meaning we need that angle 48.1 degrees, isn't it? In the second quadrant, only sign is positive, meaning cos is negative. We don't need that angle, isn't it? Then, in the third quadrant, only tan is positive, meaning cosine is negative. We don't need that angle, isn't it? Then in the fourth quadrant, cos is positive. We need that angle. So there we get the value of theta is either 48.1 degrees or 311.9 degrees. So that is the first values of theta, isn't it? Then we go for the second case. So the second case where you have cos theta to be equals to 1. So the second case, when cos theta is equals to 1, when cos theta is equals to 1, we have theta is the cos inverse of 1. So remember 1 is positive 1, isn't it? So, what is the cos inverse of 1? The cos inverse of 1 is 90 degrees or 0. The cos inverse of 1 is 0 degrees. So the cos inverse of 1 is 0 degrees. Remember the trigonometric function is moving like that. So here is 90. So you can see the cos inverse of 90. The cos 90 is 0 degrees, meaning 0 is the cos inverse of 1. Cos inverse of 1, or 1 is here, meaning that is 0, isn't it? Good. So the cos inverse of 1 is 0. So we have in the first quadrant, we have what? We have 0 degrees. In the second quadrant is 180 minus 0, isn't it? So in the second quadrant we have 180 minus 0. First quadrant we have 0 degrees. Second quadrant 180 minus 0, which is 180. Third quadrant 180 plus 0, which is 180. Third quadrant is 360 minus 0, which is 360. So we need quadrants where cosine is positive, because we have positive 1, isn't it? So where is the cos positive? The cos in the first quadrant all are positive, meaning we need 0 degrees, isn't it? Then the second quadrant only sign is positive. We don't need that because that means cos is negative, isn't it? In the third quadrant only tan is positive. Oh, we don't need that. It means cosine is negative there, isn't it? Then in the last quadrant only cos is positive. We need that positive angle. So the second solutions of theta is 0 and 360. So what are the solutions of theta? Arrange them ascending 0 degrees, then 48.1 degrees, then followed by 311.9 degrees, then 360 degrees. So after you found all the angles of theta, you look at the range you'll be told. They say only select the ones between 0 to 360 degrees inclusive. Less than or equals to means inclusive, meaning 0 and 360 are included. Are you seeing that? So it means all these angles are required because all of them lies between 0 to 360 inclusive, isn't it? All of them lies in that range. Are we together? So you now solve for theta. So that is how to solve a trigonometric equation.